take this. Let me take this opportunity to just show you. Some of you I heard you were complaining, not complaining per se, but you were struggling to get data, right? For the question, for the second question, I'm sure. Yeah. Okay, so I sent you a link on the group. Some of you, I'm sure you didn't see it, but I can always share even in the chat section. Oh, that's unfortunate. But I will share it anyway after this class. But this is the link. But even if I don't share the link, you just go to IFS. So you say International Monetary Fund, IFS. IFS is International Financial Statistics. And then you go to query. Now, this is where you can query whatever data that you want. Right, so here, let me clear all the filters that I had already inserted. I think I made a mistake here. Okay, all right. So you go here where there's this little pen here. You select the country that you want to analyze. Okay, maybe I will just take, let me take Belgium, for instance. Okay, apply. Okay, I have Belgium there. Then you choose the time. I want to go as far as 1920, but it's not necessary. Did it select? No, let me into maybe 2020. Belgium, and then the indicator that you want to focus on, there's a lot, guys. You see here, we have GDP. Someone would want to focus on GDP. Someone would, so it's you can expand the column to see what's happening here, right? So national accounts, expenditure, gross domestic product, gross capital formation, private sector, etc, etc. So you can select the variables that you want. Investment position, yeah, you just choose the variable that has captured your attention. You have capital account, debit, what. Expenditure, changes in inventory, nominal, domestic currency. So we can experiment with all these data here. We also have the industrial production index. So you have a lot of data to, it's not only inflation that you can look at, okay? GDP, you have your investment, you have consumption, expenditure, you have the exchange rate, you have a lot, equities, etc. So it's, the choice is yours, right? So there's interest rate, SDR, special drawing rights. Okay, so you can also select all indicators, but maybe, yeah, labor markets, unemployment, number of. So you see, you can get all that data. Let me just choose one. Which one can I check here? Let me see if I can get what I want. I can see others are still coming in. All right. Or did it select? Time. Okay, we start even later on, maybe from 20, yeah. Okay. Okay. All right, let me get to the class and then I will show you directly, because here I think there's something wrong that I did before I started the class. But try to experiment on your own, and then if you struggle, I'm gonna be able to assist you. Let me see. Let me start fresh. IMF, IFS, and then, yeah. you go to your where is query? Okay. So you can select here the time, and then you choose if the frequency that you want. Do you want years, or in this case, you want monthly or quarters? But I would advise you to take quarters if that's you would want. And then I would take from the first point to the last point. Okay. So in terms of years, I'm going to take quarters. I'm going to take quarters. And then I say apply. And then okay. And then you go to the country. Let me just take the one at the, okay, Angola. Apply. Okay. The indicator that you want, you just take the one at the top. I don't know what it is. Why does it not want to read? No, it's supposed to. Okay, but guys, just try to experiment, right? With this. I'm worried why it's not showing me, but it's fine. Let's proceed with today's class, and then when I get the opportunity, I'll just show you how we can do that. I don't know why today it's misbehaving, but it's fine. Let's get to today's business. Let me open the questions, and then we take it from there. How many of you are still struggling with the first question? The question number 2.
I am, Dr. Wall.
Okay, but I hope if you just navigate through that site, you won't go wrong. Okay. But we can also have another meeting maybe tomorrow or another day so that I take you through to see how you can do that. Okay, so the assignment question, let's open the question. And then today it won't be long because you're just left with this one until the last. Yeah, so I'll try to be a bit faster so that you can also have time to work on your own. Also, anyone struggling to install eViews as well? Or there's no one? Everyone is safe, right? If we are all safe, then it's fine. Okay.
Hello.
I'm still.
Your line is breaking. I can't hear
Hi.
you.
Hello. Hello. Can you hear me?
Yes. Yeah.
Hi.
Yeah, we can hear you. You can proceed.
Hello. Yeah, for me, maybe I'll need to. Now I'm saying for me, it's my first lesson, so maybe I'll need to chat with you after the lesson.
Yeah, we are struggling to hear you, but I think what you are saying
Can you
is
hear me?
It's breaking badly. It's breaking.
Hello. Okay. I'll send the chat.
Sure.
I'll send the chat.
Okay, so let me take you through the importation of the data process. I know now you are comfortable with this, but I'll go to my Word document, and then I'll take all this data. I'll copy it, but I will exclude the description of the variables. I don't need that in eViews. What I simply need is there. So I can paste here, and then I will say next, next, and then I will finish. And then I don't want to link I'll break the link, I'll say no. And then now I have my variables there. But remember, I'm doing this process again to just make sure that you understand. But we have already done this, the importation of the data. We have already transformed the data. But let me do this because there are others who have just joined us today for the first time. So yeah, okay. So I'll go back a bit to our long run equilibrium equation, whereby we need LPPI, we need LZAR, we need L oil, right? So what are we going to do? Remember here, I have the original data set which has not been transformed or which has not been logged. So what do I need to do? I need to generate new variables. And I said you can generate using this. You can generate a new variable that is called LPPI using this generate option, or you can use the command window whereby you are saying GE generate new variable that is called LPPI, which is equals to the logarithm open bracket of what? Of PPI close bracket. You see that by pressing enter, a new variable is generated. I generated a new variable that is also called LZAR, remember? So I say generate. I can't show you how to download eViews now, but maybe on a separate note, because I indicated on the group to say anyone who is struggling so that I can show you, take you through the process one-on-one so that we don't disadvantage others who have already installed. But even tomorrow or even after the class today, I can be able to take you through, right? So let's proceed. How many variables do I want to generate? I want to generate LZAR. So I will say LZAR underscore do is equals to the logarithm of what? Of ZAR underscore do, close bracket. Okay, generate was a mistake there. I have to put an R. Right, a new variable LZAR has been generated, and then I generate again. So if you have already done this, you have saved your work file already, that is good, your new variable, you don't need to redo the process again, right? You understand what I mean? Okay, I'm doing this because I can't just continue from where I left because I've run the model already. So I want to take you through the process. So sorry if this might be a delay in what you already know, but I hope it can help someone. So the last variable that I wanted to generate is L oil is equals to what? The logarithm of oil, the original variable. And then I have now my three variables. The dependent variable is the PPI. The independent variables are two. We have the exchange rate and the price of oil. So now I want to run my model. Let me maximize so that everyone can see. Let me bring this at the center. What do I need here? I need to have an equation that says LPPI on the left-hand side, constant term, LZAR, and L oil. So this is what I'm going to do now. It's very, very, very simple. We have done this in a previous class. So what am I going to do? Right, I will select, let me put them side by side so that you are not get lost. You won't get lost as well. So now I'm just moving across the screens, but I hope you won't get lost. So this is my dependent variable, which depends on whatever happens on the what? On the left-hand side. Let me maximize. So don't worry, guys, if you are like, it doesn't make sense now because we don't have the theory yet. But I will take you to the theory to say, okay, whatever we're doing in the assignment, now this is what it means in theory. So don't worry. So we have the dependent variable, which is LPPI. I select that. So you hit your control key on your keyboard, you keep it down, and then you select beta 0. Beta 0 is your constant term. We indicated that before. And someone asked to say, when I imported the data, I don't remember seeing C. So if you open C now, there's nothing in there. It's just a placeholder. But once we run the model, even the receipt, there's nothing in the residual. But we'll get values once we run the model. So I will select the first LPPI, I will select the constant term, I will also select the next is LZA, DO, I will select L oil in their order like that. And then I click, right click, like this. And then I say open. Or you can copy. You don't say, no need to say open. In some e-views, you can actually say open as, and then you can open as an equation. That would be the quickest way. But I think I'm able to do that after I've saved my file, work file. Let me just save it. Let me just save it so that, let me save it. Okay, let me put it anyway, even here. We save final. Question 3. F1. Okay, let me put the date. Today's date is 09 05/23. Okay, now I think if I say, oh, still it's not doing that, but it's fine. Let me copy. I will copy my variables. Why am I copying? Because I can just go to quick and I say estimate equation, and then I will type in my variables one by one to say, what is the dependent variable? It's LPPI. What is my, I put my constant. What's the next variable? It's LZA, DO, what. But in typing, you can make a mistake. That is why I said copy. And then I'll just paste them as they are now. So you can see that they are appearing, no mistakes in copying and no mistakes in pasting. So I will say, okay. And then now I have my regression equation, which is this. And just to make sure that my answer is okay or is correct, let me compare with what I have shown you previously in our class. In the long run regression equation, that is what we are looking at here. Long run, yes, is this one. So let me open side by side so that we are all happy. Okay, so my constant term is -820,696. Then my beta 1 is 0.78. We can agree that the answers are the same, right? They are the same.
Yes. Yes.
Okay. Just to make sure that this, because you can make a mistake. A simple mistake can result in everything here being wrong. And when you make your long run equation is wrong, which means your residuals will be wrong as well. And your error correction model is wrong. And your graph as well will be wrong. So get it right here. Okay. So we have verified that our R squared, I've highlighted it, adjusted R squared is 0.8465. Yeah. So it's fine. So what do I need now? Let me go back to the question so that I don't lose any of you here. The question says, evaluate the potential long run equation. Okay, we have done that in our previous session. There's a video that you can listen to if you're just joining us today, where we explained this, right? So what I want now is to generate residuals for your long run equation, right? So what you can do, you can come and say, I told you last time that you can just say generate. Okay, let me minimize this one because that's not what we want to use. Generate, and then you type a new equation which generates your residuals, right? But that way, yes, it's fine, but you can use another way which won't give you problems. What you do, you say, you go to view, oh, sorry. Let me go back to the estimation output. Where do I get it? It's here. Right. So you get your estimated equation, right? Or your estimated estimation results. You go to view, and then you say, anyone who can see residuals, make residuals, yes. You say make residuals. So you go to proc, right? Proc, and then you make residuals, and then you name the residuals according to your name, right? So my name is Well. So I will say res, according to the naming convention that we are given here. So we say, name your residual series as follows. Res underscore, the first 3 letters of your name. Res underscore WE, like this. First 3 letters of your name. Okay, and then you say okay. The moment you say okay, you can see that now we have the residuals by the name well. Right. Anyway, by doing that already, the new residual series are appearing here. 100%. And also, can you see that when you do this now, you can see that you have now your C. We now have the C. The C values have been filled in. Because by default, it will be 0, 0, and the same applies for residuals as well. But once we run the regression equation, the residuals will now appear. Okay, we've done that previously. Let's go to the next question now. Demonstrate how you would use the residual series to test if co-integration exists between the variables in the long-run model. So I will open again my residuals, res well, and then I will test for the stationarity of the residuals. And I said for the residuals, we don't use these models, intercept or trend, we use none. So you go to none and then you say, okay, and then you check your probability to see if it is less than 1%, less than 5%, or less than 10%. So this probability here is less than 5%. Since if it is less than, because this is 4%, right? 0.04 is 4%. Or if you want to round, you can say 0.041. Okay, or just take it as it is, it's fine. So what do you conclude in terms of the stationarity of the residual? The null hypothesis says that res well is a unit what? Root. And then what is our decision rule? The decision rule is to reject this null hypothesis of unit root when the probability value is less than the probability value is less than the significance value. Significance, it can be 1%, 5%, or 10%. So we can reject the null hypothesis at 5% and conclude that res well is stationary, or res well does not have a unit root. So when we conclude that, I will go back to the answers as well to just show you evaluating. Yeah, we explained that previously. And then now generating the residual series, I am telling you that. So here, remember, when you're explaining your residuals, you use your own residual name. Don't use res well, because this is my own residual. That's where most students get it wrong. Here. After generating the residuals, what is the name of your residual? It's res whatever. We test for the stationarity of the residuals. If the residuals are stationary, we conclude that the co-integration between the variables in the equation is present. Or in other words, we conclude that the variables in the long-run equation are co-integrated. In other words, they have a long-run what? Relationship. But where our model is here, yeah, the long-run equation or the long-run estimation. This is our long-run equation. So we have tested for stationarity of the residuals and we found it to be stationary at 5% level. Therefore, we conclude that the residual is stationary at 5%. This is a revision because we've done this previously in our previous class, right? And we've generated residuals. This part here, it was not asked in your question, right? They said just test, but you can just present the table or this output to indicate what you are saying on your what? On your, don't highlight like what I'm doing. I'm just doing this for your, so that you can quickly see what's going on. So we concluded that res well is stationary at 5% level of significance. Hence, we conclude that the variables are co-integrated. Or in other words, the variables have a long-term, not long-term, long-run relationship. You might also want to specify the variables. What are the variables? We have PPI, we have our ELSA what? ELSA do. Oh, let me not include the logarithms. It doesn't matter. ZA, do, and what? And the last variable is oil. Right? They have a what? A long run relationship. Now we want to construct. So this is new stuff now for us all. If I can assume that, yeah, it's something that is new, but let's do it together. And then you see that residual is still appearing. So if you make a mistake on your residual or residuals, which means whatever that you are going to do after the long run equation will be wrong. This will be wrong, this will be wrong, and this will be wrong also. The graph will be wrong. So take your time. Don't just run the regression model once and you say it's fine. No, do it again to prove if your equation is what your variable, your estimation is correct. Because mistakes I can also make a mistake just by typing making a typo in my formulations, and then it will be wrong. Can we generate residual from the page with all variables where I generate? Yes, you can do that, but in this case, I recommend that you use pros and then make residuals. But I think the answers will be the same. But you just prove if you do it using make residuals or where's make residuals. This is I can't make residuals on this because this is we were testing for the what? For the unit root. And then another thing, guys, that I forgot to tell you, sorry for that. Please always save your equations, right? Save your equations. Let me rerun that equation again because we're gonna need it as well. So now you see, I can't find it anyway. I have to rerun again. But if I had saved it, it was going to save me time. So I'm going back to that equation and run it again. What do I have in my long run equation? Sorry for that. I forgot to tell you, but last time I think I told you. So it's LPPI, our constant term. We also have LZA. We also have oil. And then you say, not open, but copy. And then you go to quick, you estimate equation, and then you paste your what? Your variables, simple. And then you say, okay, this is what we have. So you can delete the previous equation. It's fine. And then what do we have now? We have this, and I'm sure it's exactly similar to what we found before. I always want to verify if we didn't make a mistake here. All right. 9612182. Yes, it's correct. Yeah, it's correct. But remember, guys, you have different data sets. Always remember that. Don't use the wrong data set. Automatic is a 0. Don't say I didn't tell you or I didn't warn you. So I need to save this equation. To save this equation, guys, you can just close here and then it will say, are you sure I want to delete? And then you say name. So you name your equation. You can call it equation 1. You can call it whatever, as long as you remember what your long run equation name is. So for me, I can just leave it as equation 1 like that. But maybe I say LR what? 1. Long run equation what? 1, like this. And then I say, okay. So now instead of, when I want to refer to my long run equation, instead of running it again, I just double click here and then it opens. Simple, right? Right. And then I have my residuals as well. So let's go now to the long run, to the short run equation. So now these are just terms that I'm throwing to you, but you don't understand what is the short run. What are we trying to do? I don't have time to explain to you that at the moment. I just want us to get this assignment done, right? And then we'll explain this whole process for the preparation of the exam. After the assignment is done, I will take you through the process, but don't worry. Right, so now guys, we have this equation. So this is what they are calling the short run co-integration equation. Construct a short run error correction component for your model. Then estimate the following short run co-integration equation. Copy and paste your EViews results window in your answer sheet. Then this is the model that we want to. So guys, I would advise you, if possible, to take a pen and a paper to write your variables down. To say, okay, this is DLPP, you put it there. You say this is your left-hand variable. I have beta 0, I have this, I have this, I have this. And then so that when you are running this, you don't make any mistake. Because if you leave out any variable or if you put a wrong subscript, the answer will be wrong. So let me take you through this process. Right. Here I have, there are two ways of doing it. You can transform LPPI into DLPPI. DL, we are differencing, right? I can do that. I can simply generate these variables. It's very simple. Or you may not need to generate these variables, but you can just say, let me highlight the variables that we want in this equation. What do we want? Number one, we need the dependent variable, which is LPPI, but it's differenced, right? I will difference it later. I can show you whether you can start by differencing it and you generate new variable, but to avoid a lot of, because now if I generate DLPPI, I need to generate DLZA, I need to generate DL maize and D oil, right? All those variables. Now there will be a lot of variables clustered in your what? In your work file here. So let me show you the two ways. Number one way, which is the faster way, is I select LPPI, number one. I select beta 0, which is C. I also select LZA, which is here. I select L maize, which is where? Oh, I didn't generate the variable L maize, you see? So I need to generate that variable because here I have maize. There is no logarithm of maize. What to do? Generate L what? You can put in capital letters, doesn't matter if it doesn't care about that. L maize is equals to what? The logarithm of what? Of maize. Now a new variable is there. So that's why I say, take a pen and a paper, rough piece of paper, and then you list your variables. You click one by one. Once you have highlighted the variable, you cancel it out. Highlighted the next variable, you cancel it out. So that you make sure that you are selecting the correct variables. LPPI, I'm starting the process again. LZA, L maize, L oil. Select the correct variables. Don't take oil instead of logarithm. Then there is residual. This residual is the residual that you have generated. Don't select this one because we want the one that you have selected to appear in the model. So I will say copy as usual. Very simple. And then I go to quick estimate. I paste my variables. Now, guys, this is where it gets more interesting. Why? Because in my model, I'm given DL. I'm not given LPPI. So I can say D open bracket, close bracket. Now, instead of generating a variable that is called DLPP, I can just difference it while I'm running the regression equation. Oh, sorry, guys, I didn't select, you didn't tell me that I didn't select constant. Are you guys following?
Yes, Dr. Wells.
So why did you allow me to come here without taking the constant? What's happening? Okay.
We were gonna ask you.
Oh, okay. Okay, so we have Elza. Where is Elza? Is here. So I've selected so you start with the dependent variable. You go to the constant, you go to the Elza do, you go to L maize, you go to your L oil, you go to your residual, the one that you've generated. And then you copy. The good thing is that some views, I don't know why today mine is not allowing me to do that. When you go to open, it gives you options here to open as an equation. If you do that, then you are good to go. If it gives you an arrow here to say open as an equation, then still it takes you to, instead of going to quick, what, already you'll be there by just saying open as an equation. Now mine doesn't have, I don't know why, but it's fine. So I will paste my variables. Why is the constant not appearing? Or maybe I didn't copy. Right, paste. And then I have my C there, you see? So it's LPPI, just verify, make sure. Because it's a, right. LPPI C LZA, right? LZA do, then L maize, right? And then we have L oil, right? And then we have res well, right? But guys, there are important aspects that I want you to master here. Number one, here on our dependent variable, we don't have LPPI, but we have D what? So I will say D open bracket, LPPI close bracket. I've generated a variable, but it will not appear in your list of variables. You can even generate them if you want. If you have the time, you can do that. I said I will do that, but I don't know if the time allows me to do that. So I will close again because I have DL do, right? I also have DL maize. So I will do the same. D open bracket, Someone says, where do I press on my laptop if I need to speak? Someone can help our fellow colleague here. You click on the microphone and unmute. You unmute yourself. Okay, I hope you manage. So we have DL maze and then we close bracket. We also have, right, but before I close bracket, please listen very carefully. Here we don't have DL maze T, but we have DL maze T minus 1, which means it is a lagged variable. In other words, it is L maize or the price of maize in the previous year. It's not in the current year, because remember T indicates the current period. T plus 1 is a future variable or the next year observation. So here, take cognizance of the idea that we have the LPPT, we have the LZADO-T is in the current period. We have DL maize T minus 1, which means I need to come here on maize. Inside the bracket, I will say, I will open another bracket and I will say minus 1. Whenever you do that, it knows that you are doing a lagged variable or you are lagging a variable. What does that mean? It means that maybe when the price of maize increases this year, it will not affect the PPI this year, but it will affect it next year. You understand that? Or if I want to put it in a different way, do you understand what I'm saying? On L maize, we are saying the price of maize in the previous year is going to affect the LPPI in this current period. It affects PPI with a lag. Just like, for example, if someone cracks a joke today and everyone else laughs now, right? Then there's one person who would laugh after 10 hours or after 15 minutes, after 10 minutes, after some time. So they respond with a what? With a lag. Or this time they were still processing the joke. So when everyone else is finished laughing, then they will start laughing. So it's like, it's a weird example, of course, but I'm trying to make sure that you understand what I'm talking about. So there is an increase in, for example, investment in South Africa last year. There was an increase in investment last year, but GDP didn't increase instantaneously. It didn't increase spontaneously or at the same time. But the increase in investment, the effect of the increase in investment will be seen next year or this year. If investment increased last year, we'll see GDP increasing this year. This is another example, right? The same applies. Can someone come up with an example of the operation of lagged variables? Maybe in your workplace or anywhere, so that we make sure that you understand. Yes, Musa, it's good. If you have the LPPI already, you just copy it as it is and you put it here. That's why I said there are two ways of doing it. You can generate a variable called the LPPI, you use it here. Let me see. So we are going to do both ways and see if you're going to get the same answer. So here I started the process all over again because I didn't save my work file. Right. So there's no one who wants to give an example of lagged variables, or even in the economy or even in the workplace. Okay, let's continue. So this is what yeah.
Hello. I don't know, but this one is it's the same. Remember we said the PPI and the CPI, it's having a lag, so let's not apply.
Yeah, it applies because we are saying PPI affects what? CPI, right? You remember from the explanation. So if there is an increase in producer price index, maybe this month, we don't see the CPI increasing in the very same month, maybe after 2 months or so, because CPI is responding with a lag to what? To changes in what? In PPI. So we can say maybe PPI T minus 1 affecting what? CPI in the current period. Something like that. Yeah, but it's applicable. Okay, so now, are you guys okay on this T minus 1? Yes?
So I'm so sorry. interrupt you. I wanted to ask if we'll get this recording because my laptop is about to die and I think I might lose. Yeah, I might exit the meeting because of the battery. Will this be recorded or sent through later?
Yeah, classes
Thank
are
you.
always on record.
Okay, thank you, sir.
Right, Lynette says, raise well, we don't add -1. We are not yet there. Remember, we are moving variable by variable. We are here on, and I was trying to explain to you what's happening on L maze. We are not yet there. So let's go to oil. Oil is DL oil. So I need to add another bracket as well. I will say D. Where am I now? Oh, I'm typing on the wrong, sorry. I need here D what, open bracket. So don't put unnecessary spaces on your variables. It's just one space and then D open bracket without any space. So here, if you check D oil, D oil is in the current period. It's not lagged. So we don't do anything on it. But, right, what Lynette was saying here, we have T-1. So we need to lag the residual. So the residual in the error correction model is always lagged. Don't forget that. Otherwise, you will run into a problem. I think let's verify together and see if we have done justice. We have, I'm verifying for, I don't know for the how many the time, but you can see that I have my the LPPI, I have my constant, I have my DL ZAL do, I have my DL maze, but lagged. I have my D oil, I also have my res lagged once. Everything else constant, and then I can run my model. I have this. What does this mean? Okay, we are going to that. So, because I've run this model already, I want to make sure that I'm giving you correct answers. So this is the long run equation, and then this is the what? The short run. This is we're testing the residuals. The co-integration equation is this one, where we have the dependent variable is what? Is the LPPI, and we have least square is the method, yes. So we can't have the same time, right? Like all of us, we have the same time, it becomes suspicious. Right? So you need to run these models on your own. Right? This is the sample, 106 observations. Right? Remember, this is data set 3. I want always to remind you that. So don't be surprised when you are using your own data. So start by using the data that we are using in class, data set number 3, for practice purposes before you go on to your own data. When you are comfortable getting answers that are similar to what I'm getting here, then you migrate to your own data. I'm sure you'll be 100% correct. Right, so our constant, 96. Please help me, if you see any answer that is not the same, help me to highlight it. Right, the residual is negative, 97. I believe that my answers are correct according to what I got here. So remember, you can see that you can't cheat because your residuals should highlight your name. So there's no way around that. So I'll copy this output. How do I copy? Some might ask. You remember? You can just highlight everything in this table and then you say copy and then you go and paste in your what? So you don't want to paste an output that is ugly. Like for example, you do like this, you see? It's something, it doesn't make sense. Maybe it's better to paste as a picture. You see, but the best option is this one because it just takes it as it is from your estimation equation. But I don't need this because I already have it. Allow me to delete. Okay. it's fine now. Okay, so this is what I have for the error correction model. I've pasted the output. It's 2 marks for that. So you must not spend a lot of time here. But what you must do is practice, even when the assignment is gone. Just keep on running this regression so that it is on my mind. When you do theory now, you connect the dots. Why we were doing what we are doing now. Believe you me. Okay, so now I've managed to, so now we need to evaluate statistically the error correction model. Let's go to the question. The question says, evaluate the ECM statistically. How will you improve the model? This is what we want to answer. So I have said all variables in this model are statistically significant. Where am I getting that from? Except for L maze, right? So you can see that here, statistical significance, you see, the probability is less than 1%, less than 1%, less than 1%, except for maize. So what does it mean? It means that the price of maize in this equation is not necessary. It doesn't, okay, the price of maize doesn't explain LPPI according to this equation. But all other variables like your exchange rate, yes, they do explain. Your price of oil, it does explain. Number 3, the residual, the lagged residual in this case, which is what we call in econometrics, the error component term. The error component term or the error correction term. So they are saying here, construct a short-run error component. So the error component here is this one, but the entire model is called the error correction model. Don't worry if you don't understand this, we're going to have classes for the theory part. But let's evaluate the model. What are we going to say to evaluate this model? We are going to say all the variables in this model are, but find your own English, right? Find your own English. That makes sense. Don't just try to play around with the words, but it doesn't make sense in the end of the day. So we're saying all the variables in the model are statistically significant, except for someone can say, okay, the exchange rate, okay, the exchange rate Zado, May, oil, and yeah, the exchange rate and oil, price of oil are both what? Significant in the model, except for maize. Furthermore, the coefficient of the lagged residual as well is negative. Very important. And statistically significant at what? 5% level. You can see that the probability is less than 5. Basically, the coefficient of the error correction term should be between -1 and 0. And on top of that, it must be statistically significant. So in this case, is this condition met? Yes, it is met because the error correction model, the error correction term here, the error correction, the coefficient of the error correction is negative, and it is between -1 and 0. And further, on top of that, it is statistically significant. The coefficient for as well is what? I just copied it as it is. It is negative and statistically significant. The probability value is less than what? 0.0. You can even say at 5%. No, actually this one is at 1%, right? Please correct that. 1%. So this is the evaluation of the model. We are looking at the significance of the coefficients, but except for this one, which you said is not significant. We need to have that. Right. So the question now goes on to say that, how will you improve the model? In my case, I will improve the model by eliminating the lagged
Sorry, Doc.
price of maize. Yes.
I'm a little bit confused. Can you go back at 3.4? Here you're saying the rest well is the P at the probability it's less than 0, it's 1%. I'm saying, isn't that at all? Why 1%?
Remember, we said when it's significant at 1%, then it's significant at 5 and 10.
Oh,
So you just take,
thank
yeah.
you. Okay.
It becomes obvious. Right. So, yeah. So, yeah. So, okay, I wanted to show you the question, which says, how will you improve the model? I'm going to improve this model by taking out maize, or the lagged variable of maize, out of this equation, because it's not significant. So how would you keep a variable in a model when it is not significant statistically? So take the price of maize out of this equation. That's how I'm going to improve the model. So I'll say I'll make this model look better by removing the variable, this one, because it is not significant at all. Are we clear on this one?
Just a
Well,
quick question, Dr. Wells, if I'm understanding it correctly. Is it because it's 10.37 is above 1, 5, and 10%?
yeah.
Okay.
10.37 is about, actually, this is how many? Is 10.37%, right?
Yes, 10.37%.
Yeah.
Yeah.
It's above 10%. Yeah. Yeah. So is it clear now? Can I move on to 3.6 quickly?
Yes.
Okay.
Yes, sir.
All right. So we are done with right. Remember to save your what? Your short-term model, because we're gonna need it in future. So how am I gonna save it? I will close this one as if I want to shut down the model that I've estimated, but I will need to name it. Right. So maybe I will call it the ECM1, but you can call it whatever you want. This is me. So that when I just click on it, it opens, instead of going back again, estimating everything. So I have my long run equation and I have my short run equation. Let's go to the question. The question says, oh, I forgot to answer this question. Okay, but I will just say it and then we will answer it. Comment on the inclusion of both maize and oil price in the ECM. Does this make sense according to economic theory? Right. So I would like to think that, yeah, this one is a discussion question, which is theoretical. So when you include the price, let's go to the definition of these variables. When you forget what is maize, go back, go up and check what is maize. Primary commodity prices. In this case, it's maize corn, US dollars per watt per ton. That is maize. That is the definition of maize in this case. So we are including Brent oil price, US dollar per barrel, and also the maize prices in the same equation. So to me, according to economic theory, inclusion, you may write it as I'm saying it, or maybe you're gonna change the wording, but the concept should be the same. This is my comment. What I think, inclusion of both maize and oil price in the ECM could be problematic. Why? Because both, there's highly likely to be multi-collinearity between maize and oil prices, which violates the assumptions of ordinary least squares. In ordinary least squares, we assume that our independent variables are not correlated. We assume that there is no multi-collinearity. We assume that our independent variables are not highly correlated. All these words that I'm using, they are referring to the same thing. We assume that there is no strong relationship between the independent variables themselves. What we want is to have a relationship between these independent variables, between this particular independent variable and the dependent variable, this and this, this and this. This is what we want. But we don't want oil to be related with another independent variable. When that happens, we have a problem that is called in econometrics multi-collinearity, or we have the problem that is known as collinear. You check the linear, you check the spelling. This problem is called collinearity. It is called multi-collinearity when more variables are included. So in this case, the problem is coming because maize, or if you want to write the variable, the actual description of the variable, price of what? Maize is highly correlated with the price of oil. Why? Because if the price of oil increases, it is highly likely that the price of maize is also going to increase, because oil is used in the production of what? Of maize. It's theory. You know, farmers, when they farm, what do they need? They need capital. They need inputs. One of the inputs is oil. And when the price of oil is increased, it means increased in production cost for the farmers. And they will respond to this by increasing also the price of maize. So we are likely to see a relationship between oil, price of oil, and the price of maize. So one way of dealing with this problem of multi-collinearity is to drop one of the variables, which is what we said on question 2. Is it making sense?
Not at all.
Yeah, to me also. Yeah, I'm blank.
Where is the problem?
I thought you have said, Doctor, we don't want oil, but now oil is coming back.
Hey,
Come again. We said what? We don't want? In
I
our model.
thought you've
oil
just
and
said,
maize.
you said you don't need oil because we need LPPI, Zadol, we need maize, but not oil. But all of a sudden now there's a correlation between oil and maize. So I am lost.
On this equation, or you are referring to the long run?
No, this
we're referring
equation.
to the answer,
Whatever you were telling as an answer, I was just listening to that.
The
I
number
think
3.5.3.
3.5.3. Comment
Yes.
on the inclusion of oil. What did I say? I said, maybe I made a mistake, I don't know, but let me repeat.
Yeah.
I said, yeah, it could be a mistake. Please forgive me if I made a mistake, but let me repeat so that you make sure. What is the variable that we found to be statistically insignificant here?
Maize.
That's why we said, how are we going to improve this model? By dropping maize in this regression equation. Why? Because it is not statistically significant.
Yes.
We are together there.
Yes.
Right. Now, comment on the inclusion of both maize and oil price. We are including two variables which are capturing almost the same thing. Oil prices affect maize prices. So it's better to have one of these variables in this regression, which is oil. So what am I saying? I'm saying that in our equation, we have included oil and maize. But oil prices affect what? Maize prices. If there is an increase in oil prices, it affects what? The costs for the farmers, which will lead to them increasing their own price of maize. Right. When they do that, that will also have an impact on the what? On the producer price index. But let me not go to the left-hand side at the moment. We are worried about, in econometrics, we don't want these independent variables to be correlated among themselves. We don't want what we call multi-collinearity. You can just search on Google to say, what is multi-collinearity? So that you just try to understand, even if we haven't done the theory now, but at least we have an appreciation, right? We don't want independent variables to be highly correlated. When they are highly correlated, we have a problem that I told you is called what? Problem of multi-collinearity. There's a problem of multi-collinearity. What is that problem? It is when the independent variables are
highly,
yes, we can say highly
correlated.
correlated. In this case, now we are applying, this is theory. What I'm telling you now is theory, which I believe is quite unfair that they gave you this assignment before you could have a chance to do the theory. I don't know, but it's fine. Let's not worry about that. We are worried about having maize being highly correlated with oil prices, which means we need to drop one of these variables. And which one can we drop? We can drop oil. Sorry. We can drop what? Maize, right?
Hey.
Maybe that's why I was making the mistake. We can drop maize so that we are left with oil in the regression, because the effects of increase in oil prices, they are being also included in maize prices. So we won't be sure when there's an increase in the LPPI, is it attributable to the maize effect or is it attributed to the oil effect? Because in the maize, there is oil effects there. You get what I'm saying? Hello.
Yeah,
Yes.
doctor. Yeah,
Yes.
yeah. Now it's coming good.
Coming, yeah.
Okay. Yeah, but I hope you enjoy this more when we apply theory, when we do the theory. We have done it vice versa. We have started with the application before we did the theory. But don't worry, when exam comes, you'll be good to go. Can I move on?
Yes, you can.
So does this make sense according to economic theory? So it doesn't make sense. We are answering the question. It doesn't make sense because why? This is highly correlated with this, because if this goes up, this is likely to go up. So at the end of the day, we won't be certain to whether the increase in this PPI is attributed to the increase in maize or is oil in price increases. It's just 3 marks. You don't have to go deeper there. Right, the last part, which has got 4 marks, you need to listen very carefully again here. I hope you guys, you won't end up by saying there are a lot of things that we are told to listen very carefully, but that's what it is. We can't run away from that. You need to listen very, very carefully here. Okay, I have my 2 models, this one and this one. They are the ones that I'm going to use in this case. What am I going to do? I'm going to double click on my long run equation. I put it aside. Let me maximize so that you all see. This is my long run equation, LR1. I double click the ER equation. I put it there again. Right. So the thing that I need to do here is to create a model. We haven't done that before. It's something that is new, but listen. What do? You go to object at the top there. You say new object. We don't want to create an equation. We don't want to create a geomap. All these, we want a model. So we create a model. You can name your model whatever you want. Maybe I'll say model 1. I click OK. But guys, this is where I want to paste my equations. But I can't just paste them. If you click here, like I'm clicking right now, you can see. But there's nothing. You need to go and click text here at the corner. If you can't see text, it could be probably that your window is what? Minimized. You need to play around with this. You go to text like this. And then now you are able to type. But what are you typing? Let's see. Let's take our long run regression equation. this one. I'll go to view, I'll go to representations, and you can see that I've shown you this previously, that this is the command that you use. If you want to use the command window to run an OLS regression equation, right? If you want to use it, you can just use this one. LS represents least square, is the method that we are using to run the model. LPPI is a dependent variable. C is a constant. LZDO, first variable. LO, the other variable. And then you press enter. You have this, which is similar to what you have here. Can you see that? So in eViews, there are a lot of things that you can do, but doing the same thing. You can perform the same task using different ways. Here I've shown you another way, which I haven't told you about before, because we're using the clicking of the buttons. Estimate equation, and then you paste your variables. But you can simply come here, you say LS, least square method, LPPI, C, LZA, what, and then you press enter, you're done. Let me not confuse you. Back on track. This was a digression. Let's go back to what we were doing. I said, no. Okay, I wanted to show you how you generate a model, right? New object, model, you name your model. Okay, now we are here. But if you don't press text, you won't be able to type anything. So now I'm able to type. So I'm going to my first long-run regression equation, and I say representations. What I need, guys, is this thing here, which has substituted the coefficients. I copy that. What do I mean by substituting the coefficients? Go to your long-run equation. We were given this long-run equation here, but it had beta 0, beta 1, beta 2. The purpose of OLS is to estimate these parameters or these coefficients. So what is beta 0? Can someone tell me the value of beta 0 in our regression model after estimation? Don't disappoint me. Yes, thank you.
1.8 minus 1.8.
Thank you so much. I thought you were going to do otherwise, but I can see that you are seeing the picture. Okay, what is the value of beta 2, beta 1? Let's talk. Open your microphone.
0.7.
Yeah, 0.789, right?
Yes.
The same applies for the last one. So this is the substituted coefficient. You are going to enjoy this module more because you have seen the things being applied, but of course you don't know the theory. When we now do the theory, 100%. Okay, let's now go. I've copied my model. I will paste it here. I press enter just for to make my model, my code look nice. But you don't need to necessarily to put the enter. Right. I copy again this one. Okay, I paste it there. Here, guys, this is, I don't know how I'm going to show you this. I will take you step by step. I show you a simple model, and then we advance to a greater model. Listen. Right. What does dy t mean? What does this mean? If you see dyt, what does it mean? Someone, please. We don't want to waste time. What does dyt mean? Oh, guys, we have been differencing for a long time. What does dyt mean? It's a difference variable. But when we are differencing variable, what are we saying? We are saying yt minus what?
Y1.
Yt minus 1. We are saying the current observation of yt minus its what? Previous variable. Which means I can clearly substitute the dyt here in my equation by substituting it with yt minus 1. Let's say, for example, listen very carefully because we are going to use this to explain to you what is happening in this model. What am I going to do? I'm going to say, let's say I have a model that is saying dyt is equals to beta 0 plus beta 1 d xt. So d is like a change in a variable. Oh, right. So instead of writing dyt here on the left hand side, I can delete this and I write what? yt minus yt minus 1 is equals to what? Whatever that I'm having here. To save time, I'm not going to write that again, right? But you understand that in this first equation, we have that. In this second equation, we have substituted the change in what? In yt. Are we together? Hello?
Yes, we are.
Yes, yes.
Okay, right. So for to make life easier, I can simply remain with this yt on my what? Left hand side. And then I take the yt minus 1. I put it on the other side. What am I left with? I'll be left with beta 0 plus beta 1 d x what? T plus what?
For
YT
yt
minus
minus
1.
1.
Yes, thank you. Thank you for that. So now, because remember here, this is transformed data, but I have changed my dependent variable from a transformed data to its level, its original data set. Because remember, when we differenced, we went to differences, and then now we are going back to the original variable. So that's why we have yt now, and we've taken the yt minus 1 to the other side of the equation. If you mastered this. So now if I have a lot of variables, like this, so you can't run away from mathematics when you're doing econometrics. That's what I can guarantee you. Right, so let me go to my short run equation. In my short run equation, I have dl what? PPI. But I can simply replace this dl PPI with what? Someone can tell me it will be what? Hello? Guys, you are taught 1 plus 1 is equals to 1 plus 1 is equals to 2, and then it's now 2 plus 1. Oh, yeah, you won't struggle. Okay, so it's what? LPPI what? T minus 1, right? Is it simple? Yes, it is. And then I'm replacing this. So which means on my left-hand side, I'll be having this as LPPIT. Then I take this here to the other what? Side. So I'm going just simply to add what? This. Here. So that on the left-hand side, I'm left with the original. Of course, it's not original in this case because it's lagged. But in our case, we want to take it back again to PPIT, because in real life, when you are interpreting your results, you can't tell people that when the logarithm of this one goes up, the logarithm of what goes, you want to tell them what they understand, right? You tell them in levels to say, okay, guys, when the maybe when the price of oil goes up by this, you will see that the PPI is going to increase by this much. That's what we tell them. Okay. But in this case, we have done one part of the equation.
Okay, Doc, I'm sorry. Yeah. Do we get rid of D?
For which, on the left-hand side?
Yeah.
We do.
I see now you're saying LPPI. We're no longer saying D.
Can someone try to explain?
Yes, because it is DYT. The YT is the LPP, the PPI, the LPPI, and the D. So we've transformed it to the bottom as YT minus YT minus 1. I think.
Does it make sense to you?
No.
I'm sorry, I tried.
Okay.
You tried.
Let me see if I can do something. So this is what we have. I'm saying we have D. I will start with a very simple. yt is equals to, oh yeah, dyt is equals to what? Is the current observation of t of y minus what? Is previous, right? I don't know how I'm going to present this, but allow me to say, okay, t minus 1. But we know that it's a subscript, right? It's not saying y by t minus 1. It's just saying, oh, these are subscripts. Are we together?
Yes.
Yes. Yes.
Okay. So if I have this, I said, if I'm having an equation such as dyt, let me copy. Dyt is equals to beta 0, I will call it b0 plus b1 x d what xt, right? If I'm using an equation, like I can substitute the dyt by what? Are we together there?
Yes, I'm following.
Right, together here. But if I want to be left with the original variable on the left-hand side, which is yt, so yt can be logarithms. We haven't touched on logarithms. We are just doing the first thing, differencing here. Because in our data set, remember, the first thing that we did was to take logs. After taking logs, we difference. After differencing, now we have, you can difference once or twice. So you need to know, when you want to go back to the difference, what do you do? From the difference to the original variables, you just take this thing here to the other side here. Already you are left with yt, which is what we want. So I'm going to take this and I add it here, but it will be plus, right? And this one will just be there. Is that true?
Yes. Sir.
Yeah. So by the same token, I can be able to say, since my DLPPI is equals to what? LPPI in the current period T minus LPPI in the what? The previous period. I can replace D LPPIT by this thing. Will I be correct?
Yes.
Yeah. So that's why I'm
Yes.
saying, ultimately, on the left-hand side, I'm left with L what? Is equals to all these things plus the lagged variable of LPPI. Does that make sense to you? Is it now clear?
Yes, it is. Thank you.
Okay. Right. So now I can go to my eViews. So in my eViews, what I want to do here is to say, okay, guys, what I have here is DLPPI, but on the left-hand side, I want to remain with what? With LPPI T. So what I do, I just remove the what? The D. Oh, sorry. I remove the D here. And then I come here and add what? What do I add here?
LPPI
Just like that.
T minus 1.
T minus 1. But in eViews, you don't write T. You just say minus 1. Otherwise, if you say T, it will give you an error. Simple. Guys, I've started with this one because to me, I think that could be the easiest part in this case. But when you are doing it, you can start with what I'm doing now. The first equation, the long run equation. I've started with this one, but well, it doesn't matter. The order doesn't matter, but okay, you can do what works for you. But this is already here. We have managed to move from the difference equation to an logarithmic equation, the logarithm here. But we also want to move from those logarithms to PPI, but we are going to get there on the last equation that I'm going to put here. But don't worry, I'll take you through. So on the first equation, guys, I need to make use of the residuals that I have generated, res wells. So let me explain again. how do I find residuals when I'm given an equation such as, show you, okay, let me try to write. Okay, so I have, oh, my annotator is no longer working here. I want to, okay, it's fine. Okay, let's say we have yt is equals to what? Is equals to beta 0 plus beta 1 x1 plus, remember we said an equation in general, a regression equation is got the dependent variable, it has got the constant term, it has got slope coefficient, and it has got what? The independent variable plus an error term. Can someone remind me, what is this error term? What does it capture? Going back to theory.
All
What does the
other
error
variables that has not been included.
in the equation, right?
Yes.
Yes, thank you. The error term captures the change in y that has not been included. Sorry, it captures the effect of all the other explanatory variables that have not been included in the model, but they do have an effect on y. So we want to make the error term the subject of the formula. How do we do that? We say what? Et is equals to yt minus what? Open bracket, beta 0 plus beta 1 x what? Am I correct if I say so? Is it correct?
Isn't yt supposed to be negative because you're taking it to the other side? It is positive now, but it's negative. Looks weird. I would put it at the back.
Me too, yes.
In
I would put the
econometrics,
B,
I
the
would
B
put the yt at the back. Minus
then
y.
yes, minus YT.
can you please work it out on your side? Don't say don't work it on your without computing. Try to work it out and tell me what you get. Take it slowly, but the easiest thing that you can do, guys, is simply to leave et here and bring everything else on the left hand side.
Oh, okay. I see what you mean. Okay.
Yeah, because if you want to if you want to do it the other way, it will be longer, because what you need to do now is to say, okay,
Divide
I'm
by the
bringing
minus.
I'm bringing et this side, so it is going to also be negative, right?
Yeah.
And you are bringing yt the other side, it is also going to be negative, but this one will not change. Am I right?
Yeah.
But we don't want negative et. We are going to multiply everything by what?
Negative. Okay. I get you.
Are you comfortable now?
Yes.
Okay. We don't want people who are left uncomfortable. Sometimes mathematics does that. Okay, it leaves people uncomfortable. So this is the error term. So this is what I want to do in my long run equation. In my long run equation, guys, if I come here, I go back up. So that's why I said I started with this. I don't know which one you are going to find simpler. To me, they're equally the same. But right. So this is the long run equation. So on the long run equation, I have LPPI. This is my YT. I have beta 0, beta 1, beta 2, and there what. What I need is this residual. So what will be the equation that defines UT? Can someone tell me? It will be equal to
LPPIT minus
LPP,
B0.
yes. Thank you.
Yeah.
I have first learners here, né? But you open the bracket, né?
Yes.
Everything else will be the same. Must I continue writing, or you know what is going to follow?
We know. I know.
We know. Okay. So we are saying we are making UT subject to the formula so that we are taking this to this side, and then we have our UT on the right hand side, which is UT, LT, what. Everything that we have here is what we have here. So please, guys, to make sure that these things are part of you, try to work out using a pen and a paper. Just to say, okay, if I have my dependent variable like this, how can I make UTs? You try to work it out so that when we are talking about these things, you know what is really happening, rather than just looking at these things. In mathematics, we say, when you are studying mathematics, you don't read mathematics, you work out, right? Because you might think that you know what you know, but at the end you find out that, oh, the exam comes now, you can't even make UT something with the formula. Simple stuff like this. So work out, practice. Right, we're almost done. So what I need, guys, is to use UT. But UT, I have defined UT in my regression equation as what? What was the name of UT?
As well.
Yes, thank you. So that's where I'm going now, to eViews, to show you what's happening. Right, so in my eViews, this is my long run equation. That's where I would want to make sure that I have UT on the what? Right-hand side. So instead of trying to write everything and confuse yourself, why would you do that? Just say, remove the equal sign. And then you put a negative sign. And then you put a bracket. And then you close your bracket here. But remember, an equation has to have an equal sign. You need to have equal to. You also need to have res what? Underscore. Well. Did I violate any mathematical principle here?
No, doesn't look like it.
Okay. It looks perfect, right? Now there's silence in the room. Must I move on?
Yes, Doc.
Yes,
Okay.
Doc, you
So
can.
I have generated my residuals. I've actually made the residual the subject of the formula, explained by the dependent variable minus. So someone might say, why is there minus and then minus? Because already on our regression equation, there was a minus. But Tina, when we are working out, we say minus, open bracket, whatever follows out in the bracket, right? So that's why I said, just practice working out, making residual the subject of the formula. You won't go wrong. But I'm not yet done, guys. The first thing that I've done here, I've generated my residuals, step number 1. Step number 2, I have transformed the difference equation or the short-run regression equation into its, like, I can't say levels already because we still have logarithm. But I've at least made one step back by going back to LPP. From what? From DLPP. The next step, guys, that you need to make is to now transform a logarithm to its level. If you are given a logarithm of a number, how do you transform to go back to its original number? What do you do?
You divide by the logarithm. I think.
Really?
To remove a log, wouldn't you divide, take out log?
If you are given, for example, you are told that the logarithm of x is equal to a. If you want to find the x, what do? You take an exponential.
Substitute.
You take an exponential of a. Is it not so? To remove log here, you take e. E of log is just like 1, right? And then e of a is ea. Is this first time meeting this? Hello? In other words, we are taking the anti-logarithm. You guys will be lying. You say that you haven't heard the word anti-logarithm. I bet on that.
Because you are telling us.
That one I don't believe it. I don't buy that one. Okay. We are saying that, for example, we have the logarithm of y. Log y is equals to 2. If you want to find y, what do? We raise this to the power of what? Of 2. We take if you say E of a logarithm, exponential of a logarithm, you get the actual value here. And then you raise this as an exponent. You can try to practice this, I think. Okay, let me not waste people's time. But this is what we do. So how then do we do it here? Because we have LPPI. We want to go back to PPI. So we'll say PPI is equals to EXP. EXP in eViews is regarded as what? As exponential. LPPI. I hope my model will run because I've talked too much. So now I don't know if it's going to work. But these are the 3 steps that you need to do, guys. Number 1, let me repeat that so that you are on point. Number 1, make your residuals the subject of the formula. How do you do that? You just say res well. And res well is your variable that you have generated. So that's why I was saying, if you make a mistake on generating res, then you have shot yourself in the foot. That's the end of your story in terms of getting the marks below there. So please don't do that. Don't shoot yourself in the foot by making a mistake in estimating the residuals, because you are going to cry. Okay, anyway, it's fine. We have res well. We've made res well here, the subject. Number 2, we have transformed the short run equation, the error correction model, by removing the DLPPI. And how did you do that? We know that DLPPI is equals to LPPIT minus LPPIT minus 1. We took the LPPI minus 1 and we put it on the other side. Then the last step is to transform the logarithm to the levels, which is what? PPI. I just pray my model runs. If it doesn't, guys, you have seen the steps, right? Model source. Oh, did I save my model? Yes, I saved. Oh, just save, right? I just said Control S now. I don't know. The model has been modified. Saving the modifications will compile the model. Save modifications and compile. Yes. So here, don't touch anything. Don't even attempt to do anything here. For now, for the level that you are at, don't click anywhere. But there are models that you can do. You can do a stochastic model. You can do a dynamic solution, a statistic solution, but leave it as it is. Baseline is fine. Solve complete. That is what it's supposed to tell you. If it tells you some stories here, then you know that something is wrong. So it did about 5,000 iterations to solve this problem. But within, how many seconds did it take? Solve began at 2107 and it was completed 2107. So within a split of a second, it was already what? Done. Okay, this is my model. And then what do I need now? What I need is, so this model, what it has done, LPPI 0 is the forecasted or is the predicted value of PPI. PPI underscore 0, no, not PPI. Yes, PPI underscore 0, and PPI is the original data set that we loaded in our model. LPPI now, this is what we have estimated. So we need to click the 2, and then we can open. That's what I was telling you guys to say. You can say open as an equation if you want to run an equation. I don't know why it was not coming out then, but it's fine. It's something else that what we want is to open as a what? As a group, so that we have PPI 0, the estimated one, and the actual observations. So you can see that, okay, how far is our estimated values from the original values? But to do that, you can just sketch, draw a graph, which is the last question, you see. So PPI, right? You see that this is what we have overall. Okay, let's go to the question. The question says, create a model statement. Model statement that we have used. Oh, I forgot to copy it. Because it must be here, guys. Please. Your model must be here. Model statement. You must copy your model statement as it is. So note that your residuals are still being carried over. Can't run away from that. If you make a mistake, shooting yourself in the foot. So I have my residuals as a function of the dependent variable minus everything else, close bracket. Number 2, I have transformed the LPPI into LPPI. How? By just taking LPPI previous value into what? The other side, to the other side. Lastly, I've transformed the PPI into what? Is it clear? So this is my answer that I got, which is, I think, similar to what I have here. So you can see that even if in the short run, we can have some deviations from the long run. But however, due to the error correction model, you see why this component here was negative. Why is it called the error correction model? Because when there is an error in the model, this term here is the one that corrects the disequilibrium to go back to the equilibrium. Like you can see that from here, right? So in the long run, this is the long run equation that we have estimated already, the blue line. This one now is the estimated. So you can see that in the short term, there could be some deviations, but we are brought back to the equilibrium. So it's not something that is divergent. You see that here there's a divergent, there's a deviation, but we are corrected back to the equilibrium. There is a deviation, we are pulled back towards the equilibrium. It continues like that, and then, yeah. So you see why it is called an error correction model. Any questions? So provide your model statement. What I will do, I didn't show you how you copy, right? So let me go back. I think on the graph you can say pros. Okay, no, let me like close this diagram. You copy the diagram, you paste it there, right? Where is my model? My model is here. Just click on the model, and then you go to representations, equations. No. Object, no. Where is it? Compile, scenarios, equations. Yes, you go to text. Text, remember text, right? Then you copy everything. You go to your Word document, you come, you paste it there. Maybe if you want to paste it nicely, you can do this. After doing this, you can even highlight like this, and then you can put it in a box. Like, oh, sorry. Like what I've done, you say outside border, right? And then it is nice, like this. Only that way I paste it is not really nice. Let me just paste it on a new page. I highlight everything and then I put it in a box or borders, just like that. But it's not like everyone should do that. I just did this so that it looks a bit nice, yeah. But yeah, that's it. The end of the story for assignment 1. Any questions?
No, except tomorrow I'll reach out Dr. Wells for question 2. The data.
Okay, data is not a problem. I think I've given you a new link. It's only that I don't know why it was not performing for me. Okay, download. But if you are good, you can just play around here. I know you manage, you know? If you fail, then you can tell me if you fail, because your data should come and then you can download it there and there. And you download it. But hey, for today, let's end here. If there are any further questions, don't hesitate to indicate. If you need any further assistance regarding the assignment, you are welcome to inbox, and then we see how best we can assist each other. As of now, it has
Can I ask
been
something, Doc? Okay, I got the data from the country's Department of Statistics. Is that credible?
Yes, it is.
Okay.
Yes, it is. It is reputable.
You. Good night.
Good night. Same to you later on.
Thanks, Dr. Wells. Bye.
All right.
Thank you, sir.